Hello and welcome to 11-3 in the Big Ideas book for geometry, and we are doing areas of polygons. So many of them are going to be just regular polygons, rectangles, squares, trapezoids, but we're also going to start getting into regular polygons. So first we're going to review some terms and some different formulas that you guys have. So all of these terms: rectangle, square, parallelogram, triangle, trapezoid, rhombus, and kite. We are going to be going through here today, and we're going to be writing all these formulas for area. So area formulas. So if you know all of these formulas already in your head, then you should be good to go for now. So the area of a rectangle, that formula is going to be base times height. The area for a square is going to be side squared. The area for a parallelogram is going to be base times height. The area for a triangle is going to be 1/2 base times height. Or some of you like to write it base times height divided by 2. The area for a trapezoid is going to be 1/2 the height and then base 1 plus base 2. Rhombus and kite, these area formulas are the same. So it's the same for a rhombus or a kite. The formula is the same. And it's 1/2 diagonal 1 times diagonal 2. And they have a really good explanation on page 610 to show you where this comes from. I sometimes just confuse more people in person. It's easier to go through, but I just don't want to confuse you guys. So if you want to look up and see where that formula came from, you're going to turn to page 610 in your book, and it's going to go ahead and it'll show you what that formula, where it came from. I can show you pretty easy here where the formula for a parallelogram comes from, because if we take off this and you put it over here on this side, you can see that it comes from the rectangle. So in the rectangle, we just use this base times height to find it. And so you can see with the parallelogram, we're doing the same thing. So when I put this piece back over here, it's still base times height. Now, whether you use this height right here or any of these, as long as this comes down and it's perpendicular to both, any of these heights, these are all going to be the same length. So as long as it is perpendicular to both sides, then there's your height. All right, so area of a rectangle we already went through. We talked about the area of a square being side squared. Area of a parallelogram, base times height. Triangle. All right, so here we go. First example for area of a triangle is going to be 1/2 base times height. So if we fill in this 192 equals 1/2, and the base, they're telling us just 24, and we are looking for the height. So there's just a couple ways algebraically you can do this. So 192 equals 24h. Divide both sides by 12, and I believe you're going to get your height to be 16 centimeters. So back when you first started using the formula, you would just plug them in and find the area. Now they're going to be giving you the areas and asking if you can go backwards. All right, so finding the perimeter of the rectangle. Okay, Elliot in 4th grade right now just did problems like this. So I know you guys know how to do these, but we're just going to run through it really quick. The perimeter of a rectangle. So that means that we have area is base times height. They're telling us that the area is 154, and they tell us that the height is 11. So now if I divide both sides by 11, I can find out what that base is. And in this one right here, I believe it comes out to be 14. So now what they're really looking for is the perimeter. So if we take 2 times 11 plus 2 times that 14, that's going to give us our perimeter of the rectangle. And if I did my math right, it comes out to be 50 inches. So make sure you're putting your labels on here so I know you know the difference between 1 dimension or 2 dimensions. Okay, I just went through that and told you that this formula is going to be 1/2 diagonal 1 times diagonal 2. You can certainly look at page 610 for a clear explanation as to where they get that formula to come from. All right, so the length of this, so we're going to have 414 equals 1/2. Diagonal 1 is 23, and we're looking for the second diagonal. So after we solve and do our math on this one, I think if I did my math right, it is 36 feet for the diagonal 2. All right, last one here, finding the area. So we need 1/2 diagonal 1 times diagonal 2. Now, it doesn't look like they give us either one. Back when we were talking about kites earlier, we had mentioned that one of the diagonals, so here if we call this diagonal 1 and we call this one diagonal 2, one of the diagonals always bisects the angles, and one of the diagonals is bisected itself. So it looks like diagonal 2 is bisecting these angles in here. So diagonal 1, whoops, I wrote the same number for both of them. So let's just call this one diagonal 1. So diagonal 1 looks like it is being bisected. So this piece over here is 130. So we know that we can fill in this 130, but I need to know what diagonal 2 is. So what I'm going to do is I'm going to call this piece X and I'm going to call this piece Y. And I can solve and use my Pythagorean theorem here to find out what X is. So I can say X squared plus 130 squared equals 194 squared. So 194 squared minus 130 squared, and then remember to take the square root. So I believe that gets 144. So it's going to be 144 plus something. So now I need to do the same thing and I need to find out what Y is. So I'm going to set up 130 squared plus Y squared is going to equal that 338 squared. Because remember, the diagonals in a kite are going to be perpendicular, so we know that we have right triangles in here. So 338 squared minus 130 squared, take the square root, and I got 312. So now make sure you use parentheses or order of operations correctly. Now we're going to take 1/2 times, ooh, I have this wrong in here. This, the diagonal, is not 230 or not 130. We have to make sure that we add these two numbers together so that we need to have this whole thing, which would be diagonal 1, which would be 130 plus 130, which is going to be 260. I almost did that wrong. So 1/2 times 260 times, and then add those two together, and I got my area to be 59,280. Almost makes me want to recheck my math and make sure that I did this right. 130 times plus 59,280. Okay, and there's no units here, so I'm just going to write units squared. They didn't give anything specific. All right, the last thing that I want to cover today is a regular polygon inscribed in a circle. Now, this isn't going to be perfect, but I'm just going to do my best here. So I'm going to try and pick, I think the center's about right there. And if I drag this out, we can see as we're getting the, oh, jeepers, I missed it. All right, let me try that again. I thought that was a good one too. Drag this out, and as it get closer out, you can see that if I get it just perfect, it is going to be touching in one exact spot when it comes out. So the center of this regular polygon is also the center of the circle. So that when I draw this in, that goes out to that one point. These are all radii. And if we do that, we get triangles here. So if I'm trying to find the area of this triangle here, of this polygon, which I have a 5-sided figure here, we're going to take 5 times different triangles, base times height. Okay, so this is 5 triangles would be the whole polygon. So in order to do this 1/2, I'm just going to kind of stay out inside. And if I know that the base here, this base right here, I've got 1, 2, 3, 4, 5 of them going around. So if you take 5 times base, isn't that your perimeter of the polygon? And then one more thing that we would need here, so if we just look at one triangle that I have drawn in here, to find the area of this triangle, 1/2 base times height, here's your base. I now need the height, which is the distance from the center to a side perpendicular. Mathematicians have a special name for that piece, and that piece, when it starts at the center and goes perpendicular to one side of your polygon, this is called the apothem. A-P-O-T-H-E-M. Okay, starts at center of polygon, center of regular polygon, perpendicular to a side. Okay, that is what the apothem is. And isn't that the height of this triangle? Well, they didn't want it to call it the height. So we have a special formula for any regular polygon, and it is 1/2 perimeter times apothem. So perimeter times apothem. So in this particular figure, if I just tell you that the length of one side is 16, so I tell you the length of one side of this regular polygon is 16, can we find the area? So it's going to be 1/2, and now my perimeter, there's 5 sides, so I'm going to take 5 times, all the way around is 16, 5 times 16, that would give me my perimeter. Times the apothem. Well, if I know, I'm just going to tell you what the apothem is in this one. I would just tell you. So if that apothem is 6, now we can just plug everything in and find out what this answer is. And I think I get 240, let's just say I said meters squared. Okay, so what if I don't tell you the apothem and I tell you that one side over here is 10. So if I tell you this radius is 10, do you have enough information for you to do 1/2 times perimeter? Yep, because we still know this side right here is 16, so we can still take 16 times 5. But now if we don't know the apothem, can I figure it out if I know the radius? Well, we know that this is going to come down perpendicular, so can't we set up the Pythagorean theorem? If this is going to come down, we know this radius is congruent to that radius, so we know that this is going to come down and it's going to be perpendicular to one side because it's coming through that radius. If that's going to work to be a chord, it's going to cut it in half. So we know that this piece right here is 8, and that's perpendicular. So can we set up 8 squared plus x squared equals 10 squared? So we end up with x squared equals, what's that? 100 minus 64, 36. So we get x to be 6, which really I probably should have called it an A for the apothem. And now we can plug in a 6. So sometimes they're just going to tell you that, but I just wanted you to get used to this new formula. For a regular polygon, we can use this formula, 1/2 perimeter times apothem. Some of you are going to want to take one triangle and then multiply it by 5. You can do that. That's the same thing. 5 times this is the same thing as doing your perimeter. So you're doing the same darn thing, so it doesn't matter. All right, good luck on your assignment for today. We're going to be doing, this is 11-3, and I broke it up into 2 days. So it's 11-3, day 1.